let's label here similarity slash proportionality theorem. Proportionality theorem. Whoa, nullity theorem. I think you can mute your mic for now. And then yeah.
Okay.
Yeah, boy. So that being said, right, with the proportionality theorem, it's almost like one of those things that they're just unfortunately hated. You know, it's just sad, but that's just how it is. It's just one of those things that are just hated, but you don't have to hate it. So with the proportionality theorem, it takes into account one main factor. The main factor is that when you have one triangle, right, and you have another triangle that's obviously a bit bigger, these two triangles are obviously, if they're similar, let me just draw another shape here. I should have just copied the same image and then just made it bigger. Let me actually just do that. Let's take this whole image, copy it, and then let us paste it. And then maybe let's change the color. So we have these two triangles, right? These two triangles. The one thing that makes these two triangles similar would only be the fact that the angles are all equal. This angle equal to that one, and then this one equal to this one. So I'm deliberately only marking two angles or two pairs. The reason I'm marking two pairs is because we need to establish the fact that for triangles to be similar, you actually only need to identify two sets of angles that are equal. Two pairs is all you need to identify. And then the third ones will automatically be equal to each other because of the fact that interior angles of a triangle add up to 180. So if you spot two pairs of angles being equal, 1, 2, 1, 2, the third ones automatically are equal to each other. Now the thing is, right, if in these two triangles, obviously the different sides will be labeled as maybe A, B, C. This could be D, E, F. So what we need to take into consideration is, as long as triangles are similar, one thing that's important is the way you label your triangles. So this triangle here, you could call this triangle ABC. ABC. However, this triangle, you would want to also label it DEF. You want to label your triangles based on the angles that go with each other. So where there's A here, there's D for that one. You see, even the naming. Where there's B here, there's E here. And then where there's F for that one, there's C for that one. That's important. The reason why that's important is because we know that just visually here, without proving anything or whatever, we can see that these triangles are both similar. These triangles are similar. Triangle A, B, C is similar to triangle D, E, F. These two triangles are similar because they are three angles that are equal. You see, they are similar because angle, angle, angle. There's one angle, second angle, third angle. Those three are all equal. That's why these are similar. Now the idea is, as you may know, as long as triangles are similar, you are able to write out different expressions that can help you work out whatever you may need to work out. So the different expressions you're able to write out, you can actually generate them based on the fact that this is written like this is written like this. Even if you didn't have the picture, you already know that the line AB over DE, right? AB over DE as a ratio, this will be equal to BC over EF, BC over EF, and it will also be equal to AC over DF, AC over DF. So this is something you're always able to write out, as long as you know that triangles are similar, and as long as you write the names of the triangles in a way that is linked. You see, where you write A, you write A there. Where you write B, you write B there. Where you write C, you write C there. You see, perfect. So with that being said, this is the gist of, the proportionality theorem. The proportionality theorem, it's basically all this, but then in a way that is not just given, So with your proportionality theorem, you will obviously be asked to prove different expressions, and a bunch of other different things. Now, before we even go there, these three expressions here, expression number 1, expression number 2, and expression number 3, you basically use 2 pairs at a time based on what question is asked. So when I say you basically use 2 pairs at a time, what I mean by that is you can use these 2 together. You would have the AB over DE equal to BC over EF. Maybe you need to work out something. You can just use these 2 together. Or you can just use these 2 together here, or you can just use these 2 together there. It doesn't matter what you use. So this expression here, depending on what they may ask, you can easily, for example, do things like cross multiplying. Like if you cross multiply your fractions here, AB times this, right, can be written as AB dot EF. This times this can be written as BC dot DE. Because depending on what you may have, you obviously have questions that may ask you to prove something like this. And it all comes from writing a statement like this, comes from writing a statement like this and then choosing 2, and then also comes from writing a statement like this where you'd have proven similarity, and then it obviously then comes from you identifying a sketch or sketches that you can use to prove similarity, or that you can use to get your different lines and everything. So what I'm trying to say is, in a question, right, normally this is what is asked. They'll ask you something like prove this. But then what I'm trying to say is, for you to be able to prove something like this, you usually need an expression like this. And this expression comes from 3 sets of expressions. These 3 sets of expressions come from proving similarity. And then proving similarity is linked to proving that 3 sets of angles are equal to each other. However, we said as long as you can find 2 that are equal, that's good enough, using whatever reasons you may have. The third ones, you will be able to say that they are equal because of interior angles of a triangle. But in practice, all this will start to make a bit more sense. So all this being said, right, we said that, for proving similarity, there's one reason. The reason will be that all angles are equal. You would have identified that all angles are equal, giving reasons. And then you writing this statement, you will always be able to write out a statement like this. And your reason for writing out a statement like this with all these 3, you'll always be able to just say proportionality theorem. That will be your reason for writing out these 3 if you ever need to write them, which you obviously will need to write them depending on what is asked. So after writing out these 3, this will be your reason. Let's see. Yeah, so as long as we have these 3 theorems, right, the one thing we mentioned is that we will always be able to say that these 3 are equal because of the proportionality theorem. The proportionality theorem basically states that as long as 2 triangles are similar, the sides divide each other proportionally. You see, that's the idea behind the proportionality theorem. It basically states that if triangles are similar, yo, come on, bro, you can write similar, then the sides divide each other proportionally. You see, so meaning this fraction would be equal to that one, and it would be equal to that one in their simplest form. So this is more like the gist of the proportionality theorem without, thinking too crazy and all that. The only thing now is obviously with the proportionality theorem comes a bunch of other information, depending on what we know. Let me actually do this.